Yes, I have. Berkey, don't drink in my class, you naughty person. You're such a liar. Don't open that in my class. I got stains all over my floor from people spilling Gatorade. Tired of it. All right. No, I don't. Not in this class. During my prep hour, you do whatever I want. Oh my. Yes, very good. Okay. The region from 2 to 5. It didn't go up all the way. The garage door did not go up all the way, and she backed right into it, ripped out the bottom track. That was that. I know, but you're a man. She's a woman. We don't want her to do that. She felt really bad, especially when I had to go home last night in the freezing cold and take the entire garage door off after undoing the springs, completely disassemble it, straighten it back out, and reassemble it all back together. So I have a 14-page paper to do tonight that is due Saturday morning at 9 a.m. I will not tell my professor about the incident. I will not make any excuses for my life. I will take responsibility. Yes. Hey, that's a good idea. I will. I'm going to call Miss Miller, and I'm going to say, hey, help me with the garage door. And she'll be like, no, you need to put away your phone. Okay, here we go. 2 to 5, 2 to 5, 2 to 5. Shh. This is the curve. We are looking at it from 2 to 5, the area from 2 to 5. So you tell me, I first need to decide what the width is. What's the width of n rectangles? 5 minus 2 divided by n, which is 3 over n. Now here's the hard part. What I need to do is I now need to figure out the x sub I, what I plug in to evaluate the heights at the appropriate places. And what I do is I take my beginning value of the interval and I add on to that the width times I rectangles. So I is the number of rectangles that tells me how many widths I move over in order to evaluate it. So what's the beginning spot of our interval? 2 plus, very good, 3i over n. Now, this will not be your quiz on Tuesday, but you should be ready for this for a test that you will need to figure out area that's displaced. You have a second option as well, which I will share with you. And I'm just going to write this down once, but suppose that this was your curve, okay? Suppose you had a curve that looked like that, and you were finding the area from 2 to 5. Let me show you something you could do instead. Instead of actually adjusting it to the 2 plus 3i over n, what you could do is find all of the area in the green from 0 to 5, and then subtract off the area from 0 to 2. So you could do it twice instead if you so choose. That is one option. Some people do prefer that method depending on the type of problem that you have. So sometimes that's a quicker option. Sometimes it takes longer. So, all right, let's work it out. We need to express the area as a definite integral and as a limit of a Riemann sum. I have the integral from what? 2 to 5 of my function. What is my function? Del dx is equal to the limit as n goes to infinity All right, so we've got the limit as n goes infinity of the sum from I equals 1 to n. Shh, boys and girls. 4 plus 2 times 2 plus 3i over n minus 1/2 times 2 plus 3i over n, quantity squared. That entire quantity times 3 over n. What does 3 over n represent? The width. Okay. So we can do this. Right now, the rest of this, remember, is just really, we need to do the algebra. We need to substitute a sum. And we also then need to take a limit as n approaches infinity. So this will take a little bit of time, and I need to write it down in an extra space. What do you want? A study guide. You disrupt my class. All right. I'm going to run out of space here, and you're going to see better if I just start using a new area. So there's something really important that I need to show you, though, about this problem. And it's geometrically very important you understand. You're going to use this for the rest of the semester. Those of you who catch on to this slight subtlety in the problem will be much better off. So I'm going to write this again. The limit as n goes to infinity of the sum from I equals 1 to n of, we have 4 plus 2 times 2 plus 3i over n minus 1/2 times 2 plus 3i over n squared quantity times 3 over n. Okay, so that's what we have. Now, I want you to think of this function. You don't have to draw this, but this is very, very, very important for you to understand. Okay? If I were to take a function, we'll call this function simply f of x. Okay? And I find that area. And let's say that area is bounded from 0 to 3. And then I switch it, and I take that function, and instead of f of x, let's say I have a new function that I call f of x plus 2. That is the same function, just shifted up 2 units, correct? It does have a bigger area, but by how much? Okay? Not just 2 times the width. So you have to remember that this constant that we're going to deal with there, it just represents this rectangular area, which in this case would happen to be an area of 6. So we would have that same one, and we would add on an area of 6. So let's just think about it right now. This has a shifted height of 4 units. Over the course of a width of 3, so what area will we add on to the whole piece? 12, okay? And so we'll work that out algebraically here, but just understanding that that's going to be 12 is an important part. And so your knowledge of shifted functions really comes in handy later on when you want to be able to work through more difficult problems. Like I said, we're just looking at area right now. We're going to get to the point where we can do volume and all sorts of crazy stuff, and it'll be a really good time. Okay, let's get to work. Rotate it, but it does get a little dicey. Nope. Okay, so let's start to work this out little by little. Let's make sure we don't make a mistake. Everybody watch, because I could very easily make a mistake here. So let's make sure that we don't allow that to happen. We got I equals 1 to n of 4 plus what? 4 plus 6i over n minus 1/2 times, looks like I should square that inside, right? So I have to FOIL that. So that's going to give me 2 squared is 4. Then I have 2 times 3i over n, which is, let's do the outside inside right now. So 2 times 3i over n will be, and then double that to get, good, 12i over n. And then if I square the 3i over n, I have, good, 9i squared over n squared times 3 over n. Looks like I need a second parenthesis. Yep. Then we'll distribute the 1/2. Then we'll do the 3 over n. So we're not going to do, too many steps in one here because we want to make sure that we, again, don't make a mistake because it's really difficult to go back and try to find them all the time. So we have the limit as n goes infinity, and looks like, this is pretty easy to do. I could combine those, make 8 plus 6i over n minus what? 2 minus 6i over n minus 9i squared over 2n squared. No, hey, it's okay. We want as many people putting forth ideas as possible because that's what's going to keep us from making a mistake. Okay. Because I took half of the 12 and I got 6. I didn't want to take half of 9 to get 4.5, so I just wrote 2 in the denominator. Okay, now I distribute through the 3 over n. So I'm going to write my new limit. Limit as n goes to infinity of the sum from I equals 1 to n of, I could do 8 minus 2, 6, 6i over n, negative 6i over n. No, not all the time. 8 minus 2 minus the 9i squared over 2n squared times 3 over n. Yes. Okay, now we have the limit as n goes to infinity of the sum from I equals 1 to n. And if we multiply by 3 over n, we'll have 18 over n minus good. Did anybody find a mistake in there? No? You're good? Wait, oh, okay, like that? What's that? Okay, now I'm going to show you I'm going to show you what I believe is a nice Corbin raises a good question, and I'll be honest, I haven't really fully investigated the approach you're talking about. Corbin says, what if we multiply the top and bottom of this by 2n squared and created 1? Well, the whole idea is that we want to factor out leaving only I. So if we do combine it, it still creates a problem of how we get rid of something with an I when it's not throughout the whole piece. So we need to deal with the I's as easily as possible. So I don't really know. I'm going to say right now, I'm going to say no, that's not going to be a good option for us. Could you technically do it? Maybe so. I'm going to separate this, and this might look odd at first because it's not exactly what I've done before, but I think you'll understand why in the long run. Okay? Limit as n goes to infinity, and instead of, notice that this first piece doesn't have an I. So I'm not going to actually take out the entire piece because I think you'll understand a little bit better if I leave it there. I'm going to take out a 1 over n, and I'm going to leave it. And there are multiple ways to do this. So, there's other ways to think about this. I'm going to leave the 18. Okay? minus 27 over 2n to the third, sum from I equals 1 to n of I squared. Well, we've always done that before. But I'm going to pause the video and I'm going to show you a new sum that we can put up on the board. That rectangle piece. Okay, let's go to work. We're almost done. We have the limit as n goes to infinity of, boy, instead of this 18, I could replace it with 18n. So we have 1 over n times 18n. So 18 is our constant, and we're adding that up n times, so we'll get 18n. You can see what's going to happen with the n's. Then I have minus 27 over 2n to the third times, what can I replace for that squared piece? N times 2n plus 1 times n plus 1 all over 6. Yes. Limit as n goes to infinity of just 18. Right? Minus the limit as n goes to infinity of 27 over, we're going to have 12n cubed on the bottom. So I should FOIL this whole piece out. All right, you've done that a few times now, haven't you? 2n cubed. Whoop. Right. Well, back when we had a math induction, you really wanted that. If you want to write it like that for shorthand, that's fine by me. I'll put it on the board. Okay, so now, what's the limit of a constant? Think about that. That's a constant function. What value does a constant function always approach? Whatever that constant value is. So if I have a, think about it, if I have a function, let's say y equals 2, that's a constant, right? That looks like that. Okay? So what is the height of that function always going to be? 2. So that's the limit always. Any number, the limit of 2 will be 2. So again, the limit of a constant is the constant itself. 18. Minus the limit as n goes to infinity of, let's distribute this through. I have 54. Okay, if you want, yeah, and you're absolutely right, you guys. We'll do whatever you want. There's a number of ways to do this. I just want to do whatever you're most comfortable with the algebra. Do you just want to take out a 2 n to the third right now? Okay, I'm going to do it. I know I'm going to do exactly what we have been doing so people don't get confused. If you've got a different way, run with it, because I would do it the different way as well. But I just don't want to confuse anybody. So we've got 54 n cubed plus 3 times 27, 81 n squared plus 27n all over 12n cubed. So now we got 18 minus the limit as n goes to infinity. So now what would you want to take out of the top? Sure, we'll take out an n cubed. Left with 54 plus 81 over n plus 27 over n squared over 12n cubed. What happens to the n cubes? The n cubes will go away. What happens to 81 over n and 27 over n squared? They go to 0. Thank you for saying they don't just go away. They do go to 0. You're left with 54 over 12. So 18 minus 54 over 12. Both are divisible by 6, right? So 18 minus 9 over 2. Well, that was accounted for. Yep, that was in it. 4.5, I think. No, what happened? Oh, whoop, sorry. Yeah. Okay. 18, so 36 over 2 minus 9 over 2 is 27 over 2, or 13.5. There you go. That's what I had in my notes. So that whole idea is that you actually have a shifted beginning part. Instead of summing from 0 to something, you're starting at 2 instead. Okay? So, ready for a couple more problems? Raise your hand if you got the 3 done yesterday. Good. Here you go. I'll give you 4 more. Good practice. I'll not give you super hard, too many super hard ones, okay? Let me pause this.